number 15, it says show the function f of x equals x to the power 2/3 is not differentiable at 0. Now we can do this a couple ways, and part B says sketch the curve. So we can do this by showing the derivative is not defined at 0. We could also show this by sketching the curve and see that there's actually a kink on this curve at 0. So if I differentiate this function, f prime of x, it equals 2 over 3 x, and then minus 1 from the power, I end up with negative 1/3. So this gives me an x in the denominator. So at x equals 0, it's not defined. So not defined at x equals 0, therefore non-differentiable at x equals 0. Now, it's differentiable for every other number because 0 is the only restriction on the derivative. So it's not differentiable at 0 only, but differentiable everywhere else. If I sketch the graph of this function, I end up with a graph that looks like this, end up with a graph that looks like this, and because of the kink, right here, there's a kink in the graph, it's not differentiable at that point. Now notice that there is a coordinate there. There's actually a point at 0, 0. If I plug in x is 0, y is 0, so this has a coordinate at that point, but that coordinate, although it exists, there is no derivative that exists at that point. Okay, so because of the kink, let's say because of kink. Okay, so it's not smooth and continuous at that point. So it's continuous, but not smooth.